The following is a production of New Mexico State University.
Presentation. From 50 miles out in space, it demands attention. It is the world's largest concentration of gypsum dunes, covering 275 square miles of the Tularosa Basin in southern New Mexico. Welcome to White Sands. This extraordinary environment, located in the northern part of the Chihuahuan Desert, hides subtle life forms of exquisite beauty and surprise. But what dominates this area are the satin-like dunes of gypsum, seemingly endless sand. In some places, the dunes allow only abstraction of blue and white. In others, such as interdunal areas, the sands mingle with the hardy plants, well suited for the extremes of this environment. At times, the dunes are the silent setting for nature's sculptures. Twisted, wind-gnarled wood, botanical remnants from times past, mounds of hardened gypsum sand in bizarre shapes, cracked patterns of earth that reluctantly allow the existence of life. During most days, temperatures fluctuate 30 to 40 degrees between day and night. Winter can bring temperatures well below freezing, and summer days can easily soar into the 100s. Water is a scarce commodity. 8 inches of annual precipitation is considered average, with most of that coming from dark summer storms. Monsoon rains, which are characteristic of the area's hot season. But it is the wind that dominates this wilderness of white. It is the prominent mover and shaper of the dunes, and its influence is seen everywhere. While wind shapes and manipulates this environment, It is not the only force here. In response to wind forces, some plants react to the ever-changing dunes in remarkable ways.
One of the spectacular stories we see here on the dunes is we see these plants growing up on top of the dunes. Now, figuratively and literally, this is really just the tip of the iceberg. Each one of the plants that you see growing on these dunes are actually rooted all the way down to the bottom, because these plants didn't start on the dune, but they start as seedlings in the interdune area. But some of these plants have a remarkable ability to increase their stem growth. And as the advancing dune begins to cover the plant, the stems will start to elongate. And if the dune is not encroaching too rapidly, it's able to grow sort of above that dune as it starts to cover that plant. Eventually, the dune will advance and pass by these plants that have grown up through the dunes. And the end of the story of that, of course, is this sumac on this giant pedestal behind it. And the sumac is able to hold the soil, hold the advancing sand, and so as the dune passes over, the sumac is left there on this giant pedestal that we see behind us that's 25, 30 feet tall.
Sumac is not the only survivor working against the shifting dunes. There are places where yucca stems and roots extend from pedestals in an amazing pattern of entrenchment. Some extend 50 to 60 feet in midair as the wind has eroded away their surrounding sand. The ends of the roots still remain firmly seated in the most resistant gypsum around the main pedestal.
What we see on this yucca plant here is a remarkable story in two parts of the resilience and the adaptation of the yucca plant in the dune. The yucca actually began its growth beneath me, 8-10 feet beneath me, and the stem began to grow up and the dune advanced over it. And as the dune advanced, the stem was able to grow high in the air. Actually, down here we see the stem, and it was actually at its full growth 10 feet above us in the air. That was the first wave of the first dune. The yucca plant is unable to form a pedestal and maintain itself in the upright position, and so the initial growth of this yucca plant collapsed and fell over. Now we have a second dune beginning to encroach upon this very same yucca plant, and we see that it's responding to that by this adventitious growth of these buds beginning to grow here. And so the yucca is again going to try to cope with this advancing dune by producing another stem tissue to see if it can survive.
This botanical struggle to survive the shifting landscape can be seen throughout the white sands. Collapsed stems, emerging new growth, resilient stands. The battle is constant, but these plants have adapted far beyond mere survival. Depending on spring weather conditions, this environment can produce a colorful botanical display, an actual desert bloom.
This interesting plant here is joint fir, and it has borne on it the little flower structures. They're actual actually pollen-producing structures. And we talk about this plant flowering a lot. The true story here is that this is a conifer or a gymnosperm. And so it doesn't produce true flowers, but it produces cones, much like pine cones. One of the other names for this joint fir is Mormon tea, and this refers to the fact of the Utah pioneers as they came across the plains, ran into this plant and used it to make a beverage. And you can gather the twigs, the green twigs, and just let them steep in hot or boiling water, and it makes a beverage. This little area here is sort of dominated by this large shrub, and it's curious in the fact that we see all these flowers, yellow flowers, coming out early before the leaves. And in this particular shrub, which is skunk bush sumac, it flowers first, and then the leaves follow the flowers. Each one of these little yellow flowers will produce small red berries. The glands on the outside of that berry have a sweet taste to them and a very nice lemonade flavor to them. So skunk bush sumac is often called lemonade bush as well.
The diversity of white sands extends beyond its plant life. Even the texture of the surface varies greatly. From the slopes of a sand dune to the alkali flats to flooded temporal lakes. The question still remains, where does all this gypsum sand come from? The answer lies here, on the western edge of the dune fields, in a seasonally wet depression known as Lake Lucero.
Behind us, you see Lake Lucero, one of the main sources of the gypsum sands that forms the dunes. Most of the water that you see in the lake currently fell as rain last night. In some occasions, tremendous amounts of water fall on the mountain San Andreas behind us, and as percolate through the sediments up at the tops of the mountains, they dissolve minute amounts of gypsum out. That water is carried through the soils out into the lake, where the water evaporates and eventually deposits the gypsum that forms the sand.
Then the wind takes over, blowing the smaller gypsum particles in a northeast direction. It is this constant process of rain and wind that has formed the dunes over the millennia. This is not a recent process. Huge gypsum crystals that were formed by Lake Otero, an ancient lake of the Pleistocene age some 15 to 20,000 years ago, can still be found today. They provide an exquisite collection of color and form.
I'm kneeling down here in an arroyo that's cut through the sediments, through the muds that formed at the bottom of Lake Otero, the Pleistocene lake that filled much of this basin. These crystals that you can see in the bank and surrounding me actually formed within these muds While typically we see bladed crystals like this on the surface, actually here you can see part of a disc of gypsum that formed. These discs typically come to the surface and start breaking apart. Gypsum forms much like mica in nice sheets that break apart fairly easily along one plane. Crystals like this are probably still forming in the mud in Lake Lucero and also underneath the sands in the dune field. There are some places in the dune field where we find small crystals like this eroding out.
The wonders of present-day Lake Lucero extend beyond the world of minerals. While the lake is usually a dry bed like this, buried in the sediment below are creatures waiting for the next rain. In a spontaneous explosion, the desert's spade-foot toad emerges to enjoy the aquatic pleasures of the lake.
Behind me you can hear spade-foot toads. These desert toads only come out after a rain. You can see that this basin has been filled by rain from last night. They come out and breed quickly in these ephemeral pools.
There's two primary reasons spadefoot toads come to the surface based upon sound. The first is due to thunder. Typically when the toads will hear the thunder or vibrations, they'll come to the surface. Also, current information suggests that the raindrop impact and vibrations from raindrops hitting the surface of the soil also will entice the spadefoot toad to surface. Many ranchers in the Chihuahuan Desert have found that digging fence posts in the ground will experience spadefoot toads 5 to 6 feet deep. This just goes to show the magnificent adaptations of the species to handle the hot and dry climates associated with this area. The spadefoot toad gets its name from the black spade-like features on each of its hind feet, which are used to burrow the toad into the ground, going back first. Oftentimes it'll use it kind of pushing the dirt back and rotating its body back and forth in order to go and burrow into the ground.
They're remarkably well adapted to the desert in that the tadpoles only need a few days of water to mature into adult toads. Without that adaptation, they couldn't reproduce and couldn't survive.
As quickly as the spadefoot toads appear, they hurriedly vanish under the mud before the lake dries up. The toads are not seen again for almost a year. But on the surface of this now dry lake bed, the wind begins its work. The calcium sulfate minerals, or gypsum, washed down from the Yeso Formation of the nearby San Andreas Range, are now broken down to sand particles through wind erosion. The same occurs to the selenite crystals scattered around the shores of Lake Lucero. As weather wears away fine gypsum powder from their surface, the once translucent yellow crystals are transformed into pitted, dull white forms. Now the dune building process begins. Winds, especially the strong spring winds, blow the loose sand across the Tularosa Basin. It is during this event that nature creates a variety of dune types, each having a distinctive shape that tells much about how it was formed. To fully appreciate the diversity of these wind sculptures, one must take to the air and gain the perspective that a harrier hawk has while calmly riding the desert winds. The predominant wind direction from Lake Lucero is from the south and southwest. Close to the lake, the first of 4 dune types is found. They are called dome-shaped or embryonic dunes, seen here along the horizon. These are the fastest growing, with some traveling at the rate of 38 feet per year. These dunes are usually short, rarely higher than 6 feet in height, and very streamlined. The second type of dunes reside in areas of limited sand, but can grow to heights of 65 feet. They are called barkans, after the Arabic name for a ram's horn, which appropriately describes their shape. Their characteristic crescent form with an upward nose and 2 downward extensions repeats itself over vast areas of White Sands National Monument. The barkans are often transformed into a third type of dune, called transverse dunes, in areas where more sand exists. Here, linear ridges of sand form in a perpendicular fashion to the predominant winds. Transverse dunes, like the barkans, travel at a rate of about 12 feet per year. The fourth dune type, the parabolic dunes, can be found on the far eastern and southern boundaries of the sands. Their shape is a reverse copy of the barkans, with the nose being downwind and the two extensions facing toward the prevailing winds. These are the slowest moving dunes of the area, advancing only about 2 to 8 feet per year. As usual, nature does not always fall easily into human-created categories. Often, transition areas are found, hybrids of forms between two or several of the dune types. One can imagine that a single grain of gypsum sand will participate in forming all 4 types of dunes as it makes its trek across these expansive dune fields. Although the dunes appear static, they are in a constant state of change. In addition to wind erosion, gravity also plays a role. Many times after a windstorm, newly shifted dry sands are precariously relocated on the crest of dunes. It only takes a small shifting of the sands on the leeward side to cause an avalanche. This almost silent action of falling sand is frequent, but often not witnessed. The combination of wind and gravity allow the sands to move in a relentless migration across the Tularosa Basin. Visually disrupting this endless white wilderness is a formidable sounding place called the Lost River. This seemingly displaced body of water twists and turns through the eastern part of the basin, eventually disappearing into the base of a cascading gypsum dune.
It's a limited flow stream. It's fed by springs, natural springs that upwell into the spring. It's very shallow, as you can see. What's interesting about this area is that the salinity is very high. It's been reported to be about 100 part per thousand, which is about 3 times the concentration of seawater.
One would not expect much life in a salty aquatic environment, but surviving and even thriving in the Lost River is the incredible white sands pupfish, a fish in the desert.
The pupfish act almost as a desalinization type unit, in that they can excrete very readily the salts from their bodies, but yet maintain their water level, which allows them to survive in this environment. There's so much we can learn from them.
These amazing tiny fish, which measure less than 2 inches in length, are highly adapted to their harsh, dynamic surroundings. The waters of the Lost River can change from an extremely salty or saline composition to a predominantly freshwater condition in just a few hours due to downpour summer rains. Summertime also marks the fish's mating season, a time when the males are brilliantly colored with electric white neon stripes on top and attention-getting orange fins on the side. The flaunting coloration apparently works. Pupfish reproduce by the tens of thousands, remarkable numbers for their small and limited environment. White sands pupfish often dine on hemipterans, tiny aquatic invertebrates which also reside in the Lost River. In addition, the pupfish are cannibalistic and willingly eat their abundant offspring in order to survive. Because of their precarious existence, they have gained special status in recent years.
White sands pupfish are federally listed as a species of concern. However, the state has it listed as endangered. So it sits in 2 categories.
They also have the ability to live and withstand tremendous range of temperatures. In midsummer, the water probably gets into the 80 or 90 degree range, and in winter it may drop down into 30 degrees. The reason that these pupfish here is because they're able to withstand those tremendous ranges of salinity and temperature.
Salinity and wide temperature swings are not the only challenges facing the white sands pupfish. Over the years, Park Ranger Bill Fuchs has observed great changes in the Lost River, from drastic dune encroachment to infrequent water flow.
This is a really tough place to be for these pupfish. The water here is, maybe 2 feet wide and 50 yards, 25 yards long. And as more and more water evaporates, this whole section of river is shrinking. We're on the shores of Lost River, and as you can see, it's dry now. This is the first time in the 3 years that I've been here
that this area of Lost River has not contained water and pupfish. In all likelihood, all the pupfish that live in this section have either died or, if they were lucky, moved downstream before they were trapped in a small puddle or something that eventually dried up.
In the pupfish's constant struggle for survival, natural predators are also a threat. Bobcat, coyote, and great blue herons have been known to reduce their numbers.
You can see these raccoon tracks running right up the channel of the river. They indicate that a raccoon was coming through here and foraging, perhaps for some of the fish that were trapped as the water has receded. That's a very successful strategy for them. The fish have a limited area they can run to, and the raccoon can find them fairly easily. When there's lots of water in the river, the raccoons are much less successful because the pupfish are very quick.
Against all odds, the resilient mighty pupfish continues its existence in the Lost River. Adaptability over the long-distance run of genetic evolution has been the fish's key to survival.
This area used to be underwater during the Pleistocene epoch. It's about 15 to 20,000 years ago. And as those waters receded, these pupfish were left here in this area. And as the environment became drier and the lake started to dry up, these fish were then relegated to small pockets.
All the other fish that were in the basin have not been able to survive this and have died out. So of all the fish in the huge lake that used to fill this basin, only the pupfish have survived.
So it has some historical significance. They're a biological relic. They have a scientific value in that fish biologists can learn a lot from these little fishes. They have an enormous ability to adapt to the environment. And the white sands pupfish is found here in the Tularosa Basin and nowhere else. So I feel it's important that New Mexicans take ownership of this little fish because of this value.
As the moonrise signals the beginning of another warm spring evening at White Sands, the entire character of the place transforms. The dunes take on the colors of the sunset and eventually a shimmering glow. An entire cast of players from the insect world come out from their daytime shelters to wander the night. There's the camel cricket, whose pale coloration helps it blend into its surroundings. The bristles on its hind legs help the animal to quickly dig into the sand to escape the daytime heat. The long-horned beetle also wanders the dunes at nighttime. Another nocturnal resident of the dunes is the wolf spider. This attack on a nearby wasp nets the animal food for the day. After repeatedly biting its catch, the wolf spider then makes its way to the shelter of its home. Another predator of the night is the wind scorpion. It is harmless to people, but a deadly threat to its insect prey. But probably the most fascinating evening event involves the pronuba moth and the soap tree yucca. Every spring, these two players enter into a special symbiotic relationship, one that benefits both plant and animal. As the female pronuba visits the lush yucca blooms, she gathers pollen from each flower, and in doing this, ensures the fertilization and seed production of the plant. During the pollinization, the moth also lays her eggs in the flower as she moves about. When the moth's larvae later emerge, they will feed on the yucca's seeds, made possible from the transfer of pollen by the moth. Evidence of the symbiotic dance can be found well after the new pronuba moths have left their host.
We can shake these old seed capsules and the seeds fall out. If we look carefully, we can often find two kinds of seeds. We can find these well-developed seeds that are fully formed, but we can also find seeds with holes in them. These are the seeds that were eaten through by the larvae of the yucca moth. This is their food supply as they develop. As the larvae complete their life cycle, they will eat their way out of this capsule of the yucca flower. And if we look closely, you'll find a little hole on every capsule. This is where the larvae emerge from the capsule and drop to the ground. They complete their life cycle in the ground, and the metamorphosis from the larvae stage into the adult moth is complete, and the cycle starts over again.
Other relationships of plants and animals can also be found at White Sands, although not all are mutually beneficial. The false-toed flax, or commandra, is a parasitic plant which taps off the bounty of neighboring plants. Revealing lines of false-toed flax often follow the nourishing roots of desert shrubs. When the sands are parted, the underground story of how this plant survives is easily seen. The brilliant claret cup cactus, a member of the hedgehog group of cacti, provides shelter for burrowing mammals such as the wood rat. The soil below the plant provides the rodent with a cool, moist environment for easy tunneling. Many of the animals that wander the night can also be seen during the fringe daytime hours, around dusk and dawn. The kangaroo rat, the giant desert millipede, the darkling beetle or stink bug, the prairie rattlesnake, and the walking stick. A number of lizards common to the Chihuahuan Desert also can be found among the dunes, but here an amazing change of color takes place. At White Sands, the white or beige version of the southern prairie lizard is called the Cowles prairie lizard. Likewise, the lighter form of the lesser earless lizard is labeled the bleached earless. A pale version of the little striped whiptail is also found. Sometimes, however, darker versions of lizard species are found in the dunes. John Boren explains.
Now, you're more likely to find the darker colored lizards out on the edges of the sand dunes where there's some type of darker vegetation, while you're more likely to find the lighter colored lizards out in the middle of the White Sands. Now, on occasion, you will find a darker colored lizard out in the middle of the White Sands. However, it is most likely going to become food for a predator passing by. Major color changes observed between the lighter and darker colored lizards do take generations to evolve.
Birds are also well adapted to the vast dune areas of White Sands. Their ability to quickly travel to prime habitat areas, such as this interdunal area, makes them successful residents. The cottonwoods, yucca, and other plants offer both food and shelter. Here you will find the western kingbird, the crystal thrasher, the ladderback woodpecker, the Say's phoebe, there's the black-throated sparrow, the cactus wren, the dark-eyed junco, and the red-breasted nuthatch, here busy in its quest for insects hidden in the bark of a cottonwood tree. Over 200 species of birds have been identified at the dunes, ranging from common desert dwellers to unexpected shorebirds. A new immigrant to the White Sands environment is the oryx, which comes from the sand dunes of Africa's Kalahari Desert. This member of the antelope family was introduced to the area in 1969 by the New Mexico Game and Fish Department as exotic wild game. From the original herd of 98, the oryx have thrived in southern New Mexico and now number at least 1,500. Reports have claimed sightings of the animal east of the Sacramento Mountains, some 100 miles away. Their successful adaptation has put undue stress on the plant communities, especially in the White Sands National Monument. In keeping with the National Park Service policy of eliminating non-native animals within park boundaries, the monument built an oryx-proof fence around its entire perimeter. It is the monument's goal to eventually remove the oryx from park lands. Much of the oryx herd now roams in the surrounding Chihuahuan Desert and lives a life free of most predators. Only man, during the annual hunt supervised by the state's Game and Fish Department, keeps the population numbers in check. Otherwise, the oryx run freely in the open areas of the Tularosa Basin. Most will live a natural life and eventually pass away from old age, far from their ancestral African home. The dunes offer clues to telltale signs of even its most elusive animal residents. With a keen eye and a little practice, animal tracks can be readily identified on fresh sand deposited after a windy day at White Sands. Along the western edge of the White Sands environment, a very different kind of track can be found. Jutting up from the soil are impressions made some 12,000 years ago, when this area's climate was drastically different.
We're standing in the margins or the lakeshore of the old Lake Otero. Probably would have been full or partially full year-round, and would have been surrounded with a fairly lush grassland which extended up to the foot of the mountain slopes.
Pete Eidenbach was one of the researchers involved in an archaeological study of these mysterious tracks.
We rediscovered these mammoth tracks in the early 1980s. After looking at a number of examples that were exposed at the time, we began to realize what the formation process entailed. As these animals walked around slowly, their feet would sink in and kind of squish mud out of the way to the side. As these tracks dried and then filled with harder clay particles, they became much more resistant than the surrounding soil and gradually became a pedestal like you see here.
What's left here today is but a small reminder of the grandeur of these ancient behemoths. What exactly did they look like?
Probably a big buck male mammoth would have been maybe 1.5 times as big as the biggest African elephant, which is to say an animal that would have weighed 7 or 8, maybe even upwards of 10 tons.
Spencer Lucas, a paleontologist from the New Mexico Museum of Natural History in Albuquerque.
The mammoth that we have on display here is an average size mammoth. It's about as big or a little bit bigger than a large African elephant, about a 5 or 6 ton animal. Mammoths were grazers. They ate grass. They had these giant molars that look almost like washboard surfaces. They used to grind up the plant material. They would reach down with the trunk and pull up big blades of grass, push the blades of grass back into the mouth, and then they would grind up the grass with these big corrugated molars. The Tularosa Basin, really all of New Mexico back in the days of the mammoth, was a lot wetter and in general cooler. And there was probably grass as tall as a man, or at least as tall as a man's waist, growing throughout the basin. They represented a vast potential source of meat, of food. And so I think to the Clovis hunter, a mammoth was obviously a tempting object. It was like a huge refrigerator full of steaks walking along on the prairie.
The Clovis culture roamed the area of White Sands before the dunes were even formed. They came in search of large game, and to increase their odds, they used a weapon called the atlatl. This throwing stick allowed Clovis hunters to hurl spears 2 to 3 times faster than by hand. The speed was necessary to penetrate the thick hide of the mammoth.
The original prehistoric atlatl darts would have been pointed with a stone projectile point on a short foreshaft, which fitted into a socket in a longer main shaft. That way, you could carry lots of foreshaft and point ammunition, but only 2 or 3 main shafts. When you actually hit a mammoth with one of these, the foreshaft would stay in the animal, and if the animal ran, the vibration and the brush knocking against the main shaft would knock it out. You could recover it, rearm it with a new foreshaft, and try again. You mount the base of the spear, you grip it with your thumb and first finger, and you're armed and ready to go elephant hunting.
With the success of the atlatl, some archaeologists debate that North American paleohunters like the Clovis were responsible for the extinction of the mammoth. Spencer Lucas disagrees.
I favor the idea that Clovis man was probably a very careful hunter and only chose to kill animals that were already sick or younger animals that had strayed away from the larger group of elephants. And so I don't doubt that Clovis man had to follow these animals around, but they would have been following them around looking for an opportunity to attack a weaker animal.
Whatever the reason, all that is left today of the mammoth are its tracks and fossils. But they were not the only prehistoric animals that roamed the shores of Lake Otero.
This is a skeleton of Camelops. It's an extinct camel that lived in North America during the late Pleistocene. I find this animal very interesting when we compare it to the mammoth, which is another animal it lived with, just in terms of the different ancestry of these two animals. The camel originated in North America and then spread from North America into the Old World and into South America. The elephant, on the other hand, originated in the Old World and then emigrated to North America. Camels like this lived in the Tularosa Basin around the shores of Lake Otero during the last ice age. These animals were plant eaters. They were living out on the prairies. Herds of camels were probably living right near large groups of mammoths.
Prehistoric camels would again have been about a third larger than the modern varieties that we're familiar with. You can see that in the camel prints, which we've also discovered in this vicinity. They're about 8 to 10 inches in diameter. Almost look like oversized saucers.
In the shimmering heat, it is easy to imagine a world of mammoths, camels, and the Clovis culture. These footprints stand as unforgettable sentinels of a time long ago. They are reminders of how incredibly different our Earth was 12,000 years ago. In more recent times, perhaps 300 to 400 years ago, another group of people came to this white wilderness. Unlike the Clovis people, the attraction was not big game, for these newcomers hunted deer and elk in the nearby Sacramento Mountains. What attracted these people to the White Sands was much more basic. It was here, along the southern edge of the dune fields,
called Seryananka, meaning lower edge of sand, where we traveled to dry lake beds to harvest precious salt. Our footpaths were later replaced by a 20th century road, traces of which can still be seen today. We called ourselves Natdahindende, or the Mescal people, for our reliance on the mescal plant as a prized food source. The roots were cooked in underground pits and then eaten when needed, as this plant could be safely stored for long periods of time. Today, many refer to us as the Mescalero Apache. In addition to mescal, my people harvested over 120 other plants for various uses. In fact, plant food equaled or exceeded that of food obtained by hunting, and the role that women played as a major food gatherers greatly increased their importance within the tribe. We gathered a number of plant foods from Sethlika, the White Sands. Seeds from purple hairgrass or sandhill muley were ground into flour for bread. So were the seeds of rough pigweed, a member of the amaranth family. Its leaves were used as greens with raw or cooked meat. Indian rice grass provided not only seed, but was also cut for hay, as we adapted easily to the horse, which during the colonization of New Mexico was introduced by the Spanish. The dried leaves and flowers of rosemary mint flavored many foods, especially boiled meat. Rio Grande cottonwood supplied buds for nutritional chewing. Much like the mescal, the roots of hog potato or mesquite weed were roasted for food. Skunk bush sumac provided berries for jams, and the branches were used in basket making. Broadleaf cattail, pronounced tel, in Mescalero, was often gathered in the spring and cooked with meat. Found in the wet micro-environments surrounding the White Sands, cattails were also used during rituals. Before the stalks dried out, they were gathered during the rainy summer season. Later, the pollen would be shaken from the head of the cattail and stored in a small buckskin bag. It was an essential for many ceremonies and also used as a medicine. Several other plants had these alternative uses. Snakeweed was part of some ceremonial rites, and spectacle pod was used at times in the treatment of wounds. Another multi-use plant was rabbit bush, found along the marginal dunes. This plant was used for arrows and wickerwork. Its flowers made yellow dye possible, and the inner bark was used in making green dye. While the gathering of plants is strictly forbidden in the White Sands National Monument, special arrangements have been made for modern Mescalero descendants to gather some of these plants, just as my ancestors did.
Probably the most pronounced season of White Sands is the fall. It is most evident in the interdunal areas, those expanses of land between the dunes which offer a unique microclimate for many of the local flora and fauna. Autumn often brings a second bloom to the desert, providing that the summer monsoon rains were sufficient. Spectacle pod blooms in white abundance. Christmas cactus displays its red fruit. Other flowers like goldenweed, sartwell, and globe mallow add to the display. It becomes a busy time for the butterflies of the dunes as they take advantage of the last flower nectar of the year. you can see the painted lady, a common species found throughout the U.S. The checkered white, its scales on the wings and distinctive color patterns help attract a mate during courtship. The western pygmy blue, the smallest butterfly in North America. And the queen butterfly, an abundant resident of the West. The queen is closely related to the monarch, but unlike the monarch, this species doesn't migrate. The fall color draws attention to the fact that interdunal areas are quite abundant with plant life. But how do these plants grow in such sandy soil? The answer is here, in the life-giving microbiotic crust of the white sands. Tiny organisms, such as algae, fungi, and cyanobacteria, make up the crust, where they have made amazing adaptations to this demanding, sun-drenched climate. Soil scientist Curtis Monger explains.
This is a very harsh, light-intensive environment. Just like I have to protect my eyes from the sunlight with these sunglasses, the microorganisms also have to protect themselves. And they do this by living just below the land surface, where light can still penetrate into the soil and they can carry on photosynthesis, but yet they're protected from the overabundance of sunlight. One very important and interesting thing that the microbiotic crust does is it acts like a sponge, and it holds water. It holds water so that the roots can proliferate through this sponge and absorb water in this very parched desert environment. This is an example of a root from this grass plant that proliferates out through the microbiotic crust to absorb water. Now let me tell you how the air is important for the microbiotic crust. Air is what we're talking about, and air is primarily nitrogen, about 80%, so that the breeze I feel against my skin and the breeze moving this tree are nitrogen molecules. But the plants can't get the nitrogen from the air. That's why the microbiotic crusts are very important. They bring nitrogen from the air into the soil, and the plants get it from the soil. They make proteins, and from them we get our proteins. That's why the microbiotic crust here at White Sands are so very important. They bring nitrogen into these ecosystems.
So it is the microbiotic crust that allows plants to prosper in the interdunal areas of White Sands. The crust supports an amazing variety of life forms, some not normally associated with arid environments. Even mushrooms thrust up through the sand. What is seen above the surface, however, is just the reproductive spore-producing part of the fungi that makes up the nurturing microbiotic crust of this area. Fall often signals another event, but this one is created by humans. Balloonists take to the air for a unique look at White Sands. From high above, it is easy to contemplate its wonders. The progression of the dunes. The struggle of plants trying to outpace the encroaching sand. Animal residents adapting to this demanding environment. The wonders of this place are often subtle. But if time is taken to watch, to listen, to observe, then the rewards are great. This magnificent area, known as White Sands, is indeed a white wilderness.
The preceding was a production of New Mexico State University. The views and opinions in this program are those of the author and do not necessarily represent the views and opinions of the NMSU Board of Regents.